Here we'll be learning about solving linear simultaneous equations. There are two methods of solving linear simultaneous equations. You can either solve them by elimination or by substitution. It's up to you, but either method is highly used in further sections. In future videos will be using actually substitution. So make sure you practice substitution as well. Let's look at a couple of examples. So in the first example, we've been told to solve these simultaneous equations. That means that there are two equations and two unknowns. Alright, so one way is to make sure the coefficient of either x or y is the same. So I'm going to take x's here and say I want the coefficient. By coefficient, I mean the number in front of x's. These coefficients, I need them to be the same number so that when I add or subtract them, they cancel each other out. Now, because they're both positive, I'm going to have to subtract them so one from the other so that they cancel out. But they won't cancel away because they're different numbers. 2 minus 3 is not 0 and 3 minus 2 is not 0. But if I multiply this whole line here, I'm going to call this equation 1 and this next one equation 2. I'm going to triple or multiply equation y by 3. That means that all the values, all the coefficients will triple. That doesn't change the equation. The fact that I'm multiplying everything by 3 on that line will leave it as a true equation. I'm really not changing an equation. If I told you uh, like you have 2 sweets and your friends gets 3 sweets. Now if I say okay, I'm gonna double and give you 4 sweets and give your friend 6 sweets, the ratio remains the same. So as long as the ratio between these three values are the same, that that really it keeps it true, an equation that's not changed. I've multiplied every coefficient and the number at the end by 3. Now for equation 2, I'm going to multiply everything by a 2 because I knew that I'm going to end up with a 6 in front of the x. So the 3 times 2 is 6, negative 1 times 2 is negative 2. You don't see it, but there is invisible 1 in front of the y, and 23 times 2 is 46. Now that I've achieved my goal of having the same coefficient in front of the x, it doesn't matter whether I say, let's call this equation now equation 3 and 4. Equation 3 minus equation 4 will give me a 0 in front of the x. So if I say, I'm saying 3 minus 4, equation 3 minus equation 4. So 6 minus 6 is 0. 9 minus a minus 2 makes that 11. Why? So if you think carefully, minus a minus 2 makes that 11. So I'm really adding 2 to 9. 24 minus 46. So the difference between these two numbers is 22. But so it will be a negative 22 because uh, 46 is bigger than 24. Finally, dividing both sides by 11 will give us this. Y equals to negative 2. Now we've solved for y. We need to substitute this back in either equation. We could even use equation 1 and 2 so that we get the value of x. So if I take equation 2, for example, and say 3x minus the value of y that I just found is minus a minus, so negative 2. So I'm going to put that inside the bracket equals to 23. So that means 3x plus 2 is 23. I'm going to subtract the 2 from both sides. So 3x is 21. I took away 2. and x will be 21 divided by 3, which is a 7. Alright, so that was solved by eliminating. Alright, your book I think multiplies the second equation by 3, and that's much easier to get the coefficient of y to be the same. And you don't have to change the coefficient of the first equation. You could have just multiplied this by 3. You could have got 9x minus 3y equals to 23 times 3 is 69. Then, because I would have had the coefficient of y to be different signs, in this case the numbers match but they have different signs. So here I subtracted them, subtracted, different signs, same sign, subtract. Okay, as same sign, the number here's in front of the x we have the same sign. Here, different signs, add. Okay, so remember DSA and SSS. So that's for elimination. Once you eliminate y here, when I add them, I get 11x. This plus this gives me 0. And here I will have 69 plus 8 is 77. And again, dividing by 11 gives us x is 7. So that confirms that our answer is correct. Now I'm going to go and even show you a method of substitution with this very example, because there aren't many examples. So if I these all these red methods, writings are elimination. By the way, after you got here, you would have substituted and found y 3 minus 3. So I'm going to show you method of substitution. So this was substitution. What it is that we eliminating by substituting one variable for another. I'm going to take this equation here, equation 2, that line there. I'm going to rewrite it as with y being one side of the equation. I'm going to add y to this equation and take away 23. So I'll end up with 3x minus 23 equals to y. If you think carefully, I'm making y the subject of that equation. Now, this y is the same y that's in equation 1. So this is rewriting equation 2. Alright, so the first step is to rewrite, to make either y or x, doesn't matter which one. It was easier because y has coefficient of -1. I don't have to divide here or anything. So I made y the rewrite to make either x or y the subject. The subject. Then step 2 is to take the other equation, which in our case is equation 1, and we're going to replace y 3. There's 2x plus 3 times y. Now I'm going to open a bracket, and I'm not going to write this y here. I'm going to just leave a gap here and then write equals to 8, because that's equation 1, right? Now I know that y is 3x minus 23, so I'm going to put that where the y was. So now I see equation 1 like so, that I have literally eliminated y by substitution. So this is called by, when they say by substitution, that's what they mean to do. Now I need to multiply out the bracket and collect like terms and solve it for x. So I'll have 2x plus 9x. 23 times 3 is 69, but I'm going to write negative 69 because of the sign there. And then I'm going to write here 11x. I'm going to take 69, add it to 8, so we'll have 77. Once again, when you divide by 11, you're going to end up with the same answer. That confirms that our substitution was correct. Once you've found x to be 7, you go ahead and we could have just got this equation here, the equation 2 that we rearranged. We're going to substitute 7 into it to find y. This is nicely rearranged for y anyway. So we can say y equals to 3 times 7 minus 23. So 3 open bracket 7 minus 23. This means 21 minus 23, which is minus 2. As we found earlier, y was minus 2 there, y is minus 2 here as well. Okay, so let's look at another example where we do this substitution business one more time. All right. So in this question we have simultaneous arranged like so, and the question does tell us that we need to solve by substitution. All right. So what do we do here? We say this equation seems to be rearranged. It has a coefficient of 1 in front of y, so I can make y the subject of this again. So I'm going to add y to both sides and take away 1. So adding y to both sides and subtracting 1 from both sides will give us 2x minus 1 equals to 1. Now in this next equation, I have this y here. I'm going to use brackets and not write y. You see why? Just going to copy that. 4x plus 2. I'm going to open a bracket with a rather large bracket so I can fit stuff in it. And just write that equation. Leaving y here, not writing y. Because I'm going to substitute this value into this equation. That expression there, 2x minus 1, is y. So I'm going to write 2x minus 1 here. Now I can multiply the bracket and collect like terms and solve for x. So I have 4x plus another 4x. 2 times negative 1 is minus 2 equals to negative 30. Adding 4x and 4x, I get 8x. Minus 2, I'm going to add it to negative 30. So I'll have minus 28. Okay, so 28 doesn't divide by 8 straight away, but I know it will be negative 3.5 because, yeah, 24 divided by 8 is 3, and 4 is just half of 8, the remainder of 8. Alright, you can check it with your calculator. X is negative 3.5. Then I need to go back and find value for y. That equation is already nicely rearranged for me, so all I have to do is write 2 times what the value of x was, negative 3.5 minus 1. So this is a minus 7 minus 1 gives us y is minus 8. Alright, so how can we check these values make sense? You go back to, we just used equation 1, didn't we? So you can check with equation 2. You can say 4 times the value of x that I found was negative 3.5 plus 2 times minus 8. I'm just rewriting equation 2 here. That's why I'm putting the 2 inside the bracket. This 2 is not part of the equation, so don't confuse that. So this equation must give me 30, but I'm just going to put a question mark here and just figure out these numbers by calculation rather than writing the equation. So this is minus 14 and this is minus 16. Yes, minus 14 minus 16 does give me minus 30, which is this equation here. So it works out to be correct. So I have no doubt about, no question mark there. Alright, so we just solved this by substitution. Now, the value for the coefficient of y, you see, I made that the subject of the formula because it was nicely equal to 1. If you don't have any coefficients that's 1, you're going to have to perform some division. Alright, so I hope you get more practice done with this method. Have a go at the questions in your book, and I'll see you in the next video.